the next video, as I mentioned, that we're going to learn many things, many methods and as process just to convert from decimal to binary, decimal to octal, decimal to hexadecimal, and vice versa. So first method that we're going to learn in how to convert all base, which is base 2, base 8, and also base 16 to the decimal. And what is the method that we're going to use? So there is also a scenario on converting it too. So first of all, I want just for you to refresh that there is 4 important base number system, which is first is decimal, second is binary, octal, and lastly hexadecimal. So this is 4 base of system that you need to understand and memorize and focus in this chapter, and also digital logic. So the summations of equation is the value in decimals. So you can see over here there is a note that all example in previous slide are converting into decimal number without a total, so you can calculate it by yourself and then calculate the value of decimals to those examples. And over here also there is an example. If let's say you have base 5, how are you going to convert to decimals? And it is manually convert it using the unit to multiple, and then you will add all the multiple value inside. So how about if let's say we have the most simplest and easy way on converting those numbering system to another system. So what it is? So first of all, let's say over here, this is just still an example calculations on the numbering over here binary and convert it into decimals. So how you can easily convert it without you need to multiple, without you need to add. So it's quite long, and I can say it's manual way on converting your numbering system. So you can try all of these examples by your own. And over here you have also a simple deduction binary number. You already tried it in your previous video. So over here you have binary and then decimals, how you get these value and etc. So you already look into it all in your previous video. So now the first and all of the method that you're going to learn on conversions of decimals to other numbers bases. So how are you going to convert it? The first method is using successive division. So what is the scenario that you can apply this method to convert? So first is you need to divide the decimal number by the base of the converted value and get the quotients and also remainder. So over here, successive divides the quotients and also keep the remainder until the quotient is 0. This is very important. The answer is the string of also remainder. So you need to know also how you're going to get the answer is by read from bottom to up. So you need to remember the first key for these successive divisions is you need to read the answer from bottom 2 up, because there is another method which is on multiple and etc. You need to know another way how to read the answer. After this, you're going to get the up to bottom and so on. So first of all, for successive divisions, the key is you need to read the answer from the bottom to up. Okay, let's go deeper in these conversions under successive divisions. I give you the examples, which is you have 82 as the base of 10 or decimals. You want to convert it into the base of octals or 8. So you can see the first and all step is you need to divide it into the base that you want to convert. So this number, you need to divide it into 8. So how it looks like is like this. You have 82, you divide it with 8. And what answer you will get? You will get 8, but you will have a remainder, which is 2, because if you divide 82 with 8, you will get 10, and you have remainder of 2 over here. So you need to state the remainder and also what is the value if you divide 82 with 8. So this is the first step, and second step, you will still divide it because you need to divide until there is no possibility to divide it yet. So over here, you need to divide 10 with 8. So what your answer should be is 10 divide it into 8, you will get 1. 8 over here, you will get 2 as the remainder. So here, similar with mine, and you have a remainder of 2. And how are you going to read your answer, because you cannot divide 1 with 8. So you will get the answer from bottom to up. So this is the answer, which is 1, 2, 2, and your base is 8. So similar to here, you get the 1 to 2 as the answer. So another example, let's take a look into the second number is 42. So first, you've been given the equation, which is 42, your base is 10, and you need to convert it into base 2, which is binary. So that's why 42, you will divide it into 2, because you want to convert it into base 2. So after this, you will divide 42 with 2. What we're going to look is like this. 42 divided with 2, you will get 21, and there is no remainder. So the remainder is 0. So what next? 21 divided with 2, so you will get the answer of 10, and you get the remainder of 1. And then you divide it again, 10 with 2, and you will also get 5, and there is no remainder, which is 0. And then you keep moving with the divisions part, which is 5 divided with 2, you get 2, and remainder is 1. So lastly, you still have the possibility, and you can divide it 2 with 2, so you get 1, and also your remainder is 0. And this is how you're going to read your answer from bottom to top, which is 1 0 1 0 1 0. So this is the answer. Easy, right? Okay, now this is the table that I already share in your e-learning, so you can just have a look on this, because I do believe that you already have the basic on this. You don't need the table, I think so. So just for your reference, if let's say you forgot about your numbering system. So let's have another example, which is we have these numbers and we want to convert it into 16. That's why you're going to divide 2047 with the base of 16. So how it's going to look like? You will get like this. Please make sure don't forget to write down your every reminder, because you're going to get it as a answer. So you get the reminder of multiplications with 2047. If you divide it into 16, you get 1 to 7, but there is reminder of 15, and you need to convert it, because this is hexadecimal and the numbering of hexa is until 0 to 9, and then after that it's A until F. So 15 is F. Don't forget this is the basic one on numbering, and then you keep going divided until there is no possibility to divide it again. So that's why you will get the answer like this, and it will be 7F, isn't it? Sorry, there is a reminder over here. So 7, this one is also F, so you will get 7F as the answer. So easy, right? Easy peasy. So next, also there is also extra example. You can have a look on this, but you can also try by your own. Quite simple, as I already remind all of you. Please don't forget to start the reminder also. And yeah, over here you will get 5E7 as the answer. Try to divide by your own. So how if let's say you have, because of this one is the positive side of number, how if let's say you have a point, let's say 1.2 best 10 and etc. How you going to divide, let's say 100.52. So how you going to divide? Either you can divide it directly. Let's say you want base 16. Can you divide it with the point over here? So the next method, this method is using the division. And for the point numbering, you will learn new method, which is this method called as repetitive multiplication. So first step, you need to multiply the fractions number, if you have the point number or fraction numbers, by base of the required numbering system. And then second, you will separate the whole part of the answer and the fraction itself. And lastly, you need to repeat with the new fraction from repeats, which is step 1, until you get with the new fraction from 2. Stop when the answer of multiplication is equal to 0. Same also with the similar also a bit with adding repetitions of divisions. Now it is under multiplication. And lastly, or until reach the desired fractional point. So this is the first example. You have the 0.3125 base 10, and you need to convert it into binary. So how you're going to do is you need to multiply. Last previous method you learned on division. Now you need to have a multiple for fractional numbers. So over here, if let's say you multiple 0.3125 with 2, you will get answer 0.625, and you will pick the only beginning number. If you need to convert it into 2, please remember that this is only if you convert decimal to binary. So you will pick this in front value and you will put it into here as the reminder, like the divisions, and then you will continue using this answer. You will repeatedly, which is your first step, which is multiple, which is you need to repeat the multiplications. You repeat it, which is 0.625 multiple 2, you will get 1.25, and you pick this value and put it in here, and then you will continue. So please make sure you will get and drag this one to be out over here, and you need to know that you only take the 0.25 as the multiple part later on. So over here you will get 0.25 times 2, and your answer is 0.5. So you will drag your 0 here, and you get the balance of 0.5 also. So you will get, and then you multiple it, you get 1.0, and you drag 1 to here. So your answer currently not from bottom to up, so this answer will be like this, which is from top to bottom. So this is your answer, which is 0.0101 from top to from top to bottom, right? Okay, next example, I give you another example, which is 0.798 decimals. You want to convert to 16 base, which is hexadecimal. You can have this point, and then you multiply it into, you get this answer, and this one you drag it up, but this fractional point you will put it below, and you will keep multiply it, and you will get 12.255, and you take it this out also, and the balance of your fraction number, you put it here, and you repeatedly the multiple methods, and you will get 4.608. Take this out over here to your right, and this fraction number you need to multiply it again with 16 until you get over here 9.728, and you bring it out, and this is the reach of desired fraction point, which is this is the maximum value of desired fraction point. That's why if you check over here, you will get CC49 as the answer for your conversion from 0.798. So what is the fraction point? I already explained in a previous slide, which is also I already explained it, the maximum value numbers in the last video. So over here, if let's say you can see, you have basically whole and fraction conversions. You will give them the numbers, and then you need to convert the number to the base 8. So how you conclude is, if let's say you have the numbers, you positive numbers starting from 0 until to the positive side, which is on the left of numbers, you will use successive division. You need to divide your number, keep repeating the divisions operation. And if let's say you have the right value of number of fractions, which is over here negative side, you need to do the repetitions of multiplication system. So this is the examples. If you have both point numbers, you have positive and negative side, which is using 144 for successive division and 0.8359 for your successive multiplication. So the whole part, you will use the successive division, and the fraction part you use successive multiplication. So you need to know that for your successive multiplication, you have the end point, which is on the fractional point. So up to 3 fractional point for this number, which is under back 16. So you get the answer over here of 2EF, and over here you have 587. That's why your answer will be 587.2E5. So after you already learn on how to convert from decimal to binary, decimal to hexadecimal, and decimal to octal, we need to learn also other methods of conversion. So let's say over here binary to octal and also hex conversions. You need to convert from binary to octal by grouping bits in trees starting with the LSB less. So What is LSP? Later on you will see, and you need to remember this value, which is 3. And then if you want to convert it into hexadecimal, please remember 4. And you will start also with LSP. So each group is then converted to the hex equivalent. So leasing zeros can be added to the left of the MSB. What is MSB? Also, we will look at the next slide. So let's say you have this binary number 0 1 1 1 1 1 0 0 1 1 1 and 0. How you're going to convert? As I already informed, please remember 3 if you want to convert to octal. So you need to group it into 3 bits, starting from LSB. LSB is from your right to left. This is from LSB. The least number system over here is 0. For the MSB, later on you will see the most numbers system on your left side. So later on you will see over that. Now you need to divide it first until 3 bits. So you will starting from your right, and then you get just like this. So how it look like over here, and why you get 3, which is to the power of n equal to 8. If you want to convert binary to octal, you need to have n of the power, which is 3. That's why you need to remember of 3 from binary to octal. Now you can see similar numbers over here. You bring it out, and you need to group it into 3. From LSB, 3 bits, 3 bits, and you have basically this value of number. How you get this 6, which is to the power of 0, to the power of 1, to the power of 2. You get over here, this one is 4, this is 2, and then this is should be 1, and if you time or multiply it, you get 0, and then you get 2, and also 4. Now you get 4 to 0, you times, you will get 6. So this one is value to the power of 0, this is the value of to the power of 1, this is the value of to the power of 2. And then you will notice over here, this one is 0, so that's why you times 0 multiples to 1, you get 0 over here, and then the rest is 1 1. So that's why you get 6. And similar to this one, you have to the power of 0, to the power of 1, to the power of 2. Similar also over here, to the power of 0, to the power of 1, and to the power of 2. Here to the power of 0, to the power of 1. So easily you can convert it. Another one is on binary to hexadecimal. You need to convert and group it into 4. Why? It's because 2 the power of n equal to 16. What is the value of numbers over here? This is 4. And this is how the example, you need to group it into 4, starting from your side, LSP, you get like this, and you directly convert, and here is your answer. Easy peasy, right? So now, if let's say you have the binary fraction, 2 octal and also hex conversions. So if let's say you have the whole number, you will convert it directly using this method and step. And if you have the fraction, how it will be? Quite similar also when you have to group it with numbers, but what else? For the whole and fraction binary, the process is division into 2 steps. So first step, you need to group the whole integer part portion starting from the radix point moving to the left, and then add the necessary numbers of 0 to the left side. And if you look over here, what is the meaning of this is you need to put 0, it's like this. In this example, it should be until here, which is you will see 0, 1, 0, 0. If you by mistake you do direct conversions, and you see, oh, this is behind 1000, so that's why if let's say you need to multiple it into 4, you will put another extra 0 as to meet and group it into 4, similar to this example 2. If you need to group it into 3, so you have only 2 by over here, so please put 0 in front. Like this example, you need to put 0 in front. So go back to our slide. So this is the meaning of step 1. And then step 2, you need to group the fractional portion starting from the radix point and moving to the right. So for the whole number, you go to the left, but for the fraction numbers, you go to the right and add the necessary numbers of 0 to the right. So here is one example, which is you have 1 0 0 0 1 1 0 1 and then point 1 1 0 1 0 0 1. So how is it? You need to group 3 bits if you want to convert binary to octal, and then 4 bits if you want to convert binary to hexadecimals. So you have 2 points, which is the whole number, and then this is the fraction number. So what you're going to do for the whole is you need to group it, and you need 2 points moving to the left like this. So it is moving like this. But if let's say you have the fraction number, also you need to group it into 3, but you need to move to the right. That's why from here you will group it as like this, 0 0. So you will need to add this 0 0. So I just redraw the number, which is 0.1. So I delete first. So from here you have this fraction number, you need to group into 3 from right. Sorry, you need to group it into this number moving to the right from the radix point, from the dotted over here. So you need to move from to the right, not from, to the right. And then you calculate 1, 2, 3. You divide it into one group. 1, 2, 3. You divided it into group. And you have 1. And you need to add another extra zeros. Please don't forget this method, because if you just put 1 and you will just convert it, you get 1. But if you put 1 and then you add extra 0, you will convert it into 4. So take a look over here. This is the whole number. So you will move from right to left, and then this one is from radix to right for your fraction number. This is your fraction number, and this is the zeros that you added. That's why you will get 215.644 as the conversions of your number, binary number. So now, this is just recall to the power of n equal to 8, and you get n. So this is another example. You might try by your own. If you have difficulty and also a problem with conversions, please let me know. You can direct WhatsApp me, but I prefer you to WhatsApp in group, just because you can share with others too. And I'm having a problem with getting too many WhatsApp, and sometimes I can barely get into all the WhatsApp, and also I forgot, if let's say I already opened, I forgot to reply. That's my problem with WhatsApp groups and WhatsApp's application. So please ask me in the WhatsApp group and also in the forum that I created in your e-learning. So you need to recall which is 2 to the power of n equal to 16 if you want to convert it into from binary to hexadecimal. And another point that you need to remember is you need to move from radix point to the left if it are whole numbers, and for the fraction number you need to start from radix point to the right. So this is the example of the questions. And if let's say you want to convert, because you already convert binary to other different system of numbers or base numbers, now you will convert octa and hexa to the binary. So how about this? So first, that you need to convert every digit into groups of binary bits, which is octals is 3, hexadecimal is 4, as you remember in our previous slide. When you're converting octal to hexadecimals and vice versa, it is as advisable to use binary representative as a intermediate conversions. So before you can directly convert, you need to have these intermediate conversions. So this is the examples. You have 124.AB7 as your hexadecimal number. You want to convert it into binary. So several steps you need to do is you need to divide it into whole part and also your fraction part. And because you have this kind of number, you need to bear in mind that if let's say it is base 16 or it is hexadecimal, you will have 4 bits of numbers in each number. So will you get like this: 4, 4, 4, 4 over here. You need to convert it one by one. So if you have the base 8, you want to convert it into binary or base 2, you need to divide it into 3. That's why you will end up with this answer. Please do all these equations. Please you do all these examples just to increase your understanding, and also do some exercise to speed up your method and approaches. So this is also another example you can try also, and you will given the answer too. So over here, because you want to convert from hexa to binary, so you will get 4 as your conversion, 4 digits. So lastly, you need to know the summary of number system conversion. If you have the decimal of 10, and then you have the whole fraction, and you have also another one is fractions and also the wholes, and you need to know that if you want to convert it into hexa or binary or octal, you need to use the successive divisions, while if you have a fractions, you will use the successive multiplication. Easy to remember, right? And then how about the conversions on binary and octal? You will see like this, which is quite simple. You have base 3 and then base 4 for hexadecimal, and the conversion part you need to remember because we already go through all, and it's much more easier if you remember all of these steps. So I think only that. For numbering system, I already covered all, and I hope you have a very strong basics on numbering system, because later on we will use on focusing on binary, of course, 1010, especially for your gate, and others numbers base also important for your knowledge too. So thank you for your watching, and have a good day. Don't forget to do revisions. Bye bye.